Hello, and this time we're talking about divisibility tests. I'm just going to look at 2 to 10. You don't need to do 1 because obviously all whole numbers divide by 1. And I will say I'm going to do them not in the order going down the page. I'm going to do them in order of, relatively anyway, the order of how easy they are. And 7 will be last, and you don't need to know a divisibility test for 7. And if you're doing Edexcel, GCSE, and probably other boards as well, you get a calculator in all your exams, so you don't need to worry about checking if it's divisible by 7, because you can just divide it by 7 and see if it's a whole number. And that's a great divisibility test if you need to, and you've got a calculator. Is 1296 divisible by 7? Just divide it, and if it comes out as a fraction, then no, it's not. Or if it comes out as a decimal, no, it's not. And if it comes out as a whole number, then yes, it is. But if you wanted to test something without a calculator, maybe in a UKMT Maths Challenge or something like that, then here's how we're going to do it. So start with the easiest one, divisibility by 10. Does it end in a 0? If it ends in a 0, it divides by 10. If it doesn't, then it doesn't. So 1296 does not divide by 10 because there's no 0 at the end, but 210 does, because you can divide by 10 and get 21. That should be relatively straightforward. Okay, next easiest one is probably 5. Does it end in a 5 or a 0? So I'm sure you know the 5 times table, 5, 10, 15, 20, 25, etc. It always ends in a 5 or a 0. So if it does, if you've got 1985, then yes, that divides by 5 because it ends in a 5. If you've got 1997, then no, because it doesn't end in a 5 or a 0. So again, quite a straightforward one. We'll move on swiftly. Okay, next easiest is probably the 2s. Does it end in an even number? If it does, then it divides by 2. So 1296, yes, 6 is an even number. 203, no, 3 is not an even number. Divisibility by 4 is somewhat similar, but do the last 2 digits divide by 4? And that's because 1296, let's look at that, 4 doesn't go into 10, but it does go into 100. It goes in 25 times. So anything above 100, we know that 1200 divides by 4. And so all we have to do is work out if the last bit does. Does 96 divide by 4? And if you can halve it, so you could just say, well, I know that divides by 4 for whatever reason. You recognize its number. If it ends in 16, well, I know 16 is in the 4 times table. Not so sure about 96, so you could just halve it. Okay, so half of 90 is going to be 40, and we're going to carry the 1, and that's 16, and half of that, so it's 48. And because this still divides by 2, it's still even, then we know that that's going to divide, that whole number divides by 4. We know this divides by 4, and therefore we know the whole thing divides by 4. And so halving it and then checking whether it divides by 2, that will work. And so 8 is very similar as well, but we have to go to another digit. We have to look at the last 3, because 8 doesn't go into 100, but it does go into 1,000. So we know that the 1,000 is fine. 8 goes into that 125 times, but we have to check the 296. And again, because it's just 2 times 2 times 2, we can just do it by halving. So we can say, okay, what's half of this? So that's 100 plus 45 plus 3. So what's that? 148. So now, if this number divides by 4, then we know that this thing divides by 8 because we just halved it. So we don't need the 1 anymore. We just look at the 48. Does that divide by 4? Well, you might recognize that yes, it does. But just in case you don't spot that's in the 4 times table, let's half it. That's going to be a 2 and a 4, 24. And if this, because we've halved it and halved it again, if this divides by 2, which it does because it's got an even number, then we know that that's divides by 2, therefore that divides by 4 because it's twice as big, therefore that divides by 8, and therefore the whole thing divides by 8. Okay, so just looking at the last 3 digits there, and this halving and halving again works because 8 is double 4, which is double 2. Okay, so 3 is probably the next one, and for this one it's the digital root. and does that divide by 3? So let's go back to our 1296. A digital root is where you add the digits together. So if you just add all that together, we've got 1 plus 2 is 3, plus 9 is 12, plus 6 is 18. And if you're not sure, well, I don't know if that divides by 3, because you just don't know the 3 times table very well, you can just do the digital root again. 1 plus 8 is 9, and hopefully you can see that 3, 6, 9, it is in the 3 times table, so yes, this one does divide by 3. But you can also be a bit clever, because if a number divides by 3, you don't need to add it up. So 6, I don't need to add that up. I know that divides by 3, so it's not going to upset my digital root. 9 divides by 3, so I just have to do 1 plus 2, and if that divides by 3, which it does, it's 3, then it'll divide by 3. So if you've got a big old number like this, 5, 7, 9, 3, 2, 1, 6, then we can test for divisibility by 3 really quickly. Ignore the 9, ignore the 3, ignore the 6. 2 and 1, that makes 3, so I can ignore that. And then I just have to look at this. 7 plus 5 is 12, and 12 does divide by 3, so that whole thing, yes, it divides by 3. Dividing by 6, you can just do the 2 tests for 2 and 3, and if it works for 2 and 3, it will work for 6. So if we go back to this one, so if I just undo some of that scribble, so I can read the number again. There it is. So the divisibility by 6, does it divide by 3? Well, we just checked that, and yes, it divides by 3. And then, does it end in an even number? Yes. And it must satisfy both of them at the same time. If it does both, then yes, that will divide by 6. 9 is very similar to 3 in that you do the digital root, but it has to end up as a multiple of 9. So this one didn't work. Oh, wait, it might have worked because we didn't add everything up, did we? Okay, so I have to do it again. This time, like we could ignore 3s before, now we can ignore 9s. So I'm going to ignore that 9, because that definitely divides by 9. 6 and 3, that makes 9, so we can ignore that. And now we've got to add up these. So 5 and 7 is 12, 13, 14, 15. 15 is not in the 9 times table. So this guy does divide by 3 and 6, but it doesn't divide by 9. This chap does, though. So if I just delete those, if we go back to our 1296, when we added it up, we got 18, which is in the 9 times table. It does divide by 9, so it is divisible by 9. And if you add those together, you get 9, which obviously does divide by 9 because it's 9. But we can also do it by the deleting thing. Say, delete the 9, and then 6, 2, and 1 is 9, so it divides by 9. So those are all quite neat. And although, yes, the correct answer for how do I see if something divides by something is, well, just do the divide. And you could either do bus stop method, does 1296 divide by 42? I don't know. You could do the long division if you wanted to, or you could get the calculator and type it in. But if you don't have a calculator, no, it doesn't go in. If you don't have a calculator, then there are these little tricks just to see if it will divide. What about 7? Well, I did say you don't need 7, so feel free to turn the video off now. But if you want to know how to do 7, you double the last number and subtract it from what's left. And if the result divides by 7, then you're good. So let's do 1296, which we know doesn't work, but let's just see how it works. So you cut the last number off, and you double it, so 6 becomes 12. So 129 is the remaining number. Take double the last number away, and we're going to get, well, that's 117. Does that divide by 9? Divide by 9. Does that divide by 7? Well, actually, I don't know. I'm not very good with my 7 times table that high, so I'm going to do it again. I can do this trick again and again and again. It doesn't make a difference. So I'm going to double the last number and take it away from the front. So 11, take double that number is 14, and that's going to give me -3. Well, -3 does not divide by 7. If it had been -7 or -14, you could say, yes, it doesn't matter if that comes out as a negative, if it comes out as a negative that's a multiple of 7. But 3 is not in the 7 times table, so no, that doesn't divide by 7, and we knew that anyway. But let's take a number that we know does divide by 7, so I don't know what that might be, but let's pick something like 30, no, let's say 13 times 7. What's that? 91. Or let's go a bit bigger. Let's say 24 times 7. So it's a bit bigger. 168. Let's test this one. Cut the number off. 16 take away double that. Oh, 16 take 16 is 0. Well, 0 does divide by 7. You get 0, but that's absolutely fine. That does divide by 7 because 0 is a multiple of 7. It's the 0th multiple of 7, I suppose. Okay, let's try another one. So let's go for 1468 times 7. So this is going to be a big number. 10276. Okay, let's get rid of this. 10276. Is that right? 10276. Cut the last number off. 1027 and take away double. So take away 12, we get 1015. No idea. So let's cut that off and say it's 101 take 10. Okay, well that would be 91. Does that divide by 7? Well, actually, yes, it does, because we saw that just a second ago when I did one of the numbers times 7. But let's assume that we didn't know that. Still not sure. Should be able to divide it in our heads, but let's do the method anyway. 9 take double the 1, which is 2, and we get 7. And yes, 7 divides by 7, so that means 91 divides by 7, and that means that 1015 divides by 7, which means that the number I had up here divides by 7. And if I divide that by 7, well, it should work because we made it by times it by 7. Yes, indeed, it divides by 7. So hopefully you can see that all of the divisibility tests, 2 to 10, are quite nice. Even 7, you have to remember how to do it, but even that is quite a neat little way of doing it. But certainly you don't need that one, but 2 to 6 and 8, 9, 10 are very useful. If you have any comments or questions, then pop them down below, but otherwise, cheerio.